I'm Sammy Williams, and I was a project manager for the RE-RASSOR project.
My name is Diego Zamora. I worked with Ross in this project, and I was in charge of improving and optimizing the task scheduling system for ReRassor.
My name is Zach Tapman, and I used ROS to help optimize the task scheduling system of ReRassor.
Hello, I'm Jordan of the RE-RASSOR Gold Team, and I worked on a front end for a rover swarm.
My name is Jeremy Dantes, and I was in charge of the hardware integration for the ReRassor project.
So RE-RASSOR is to take NASA's Mega Razor and make a research and education version of it so that students like us and other researchers can go and 3D print their own body. They can get the parts they need for relatively cheap and use our open source software to put it all together. What our current goal was to take the open source software and put it on actual hardware so it can be out in the world and you can see it driving around, and we were tasked with improving the swarm function of the rover.
One of the broader impacts that ReRassor has is that because it's open source, it allows for contributions from all types of researchers and students and other programmers alike. This allows for NASA to take ideas that may start out in ReRassor and scale them up into their own design in their own rovers. The other thing is that because ReRassor is such a low-cost project, it allows for reproducibility, and other students and researchers can make their own razors and conduct their own individual research.
So generally, most of our testing was done on Gazebo, which is simulation software. What we would do is we would have our changes and we would test them locally on a machine running the simulation. And in combination with some ROS services and some ROS tools, we would debug and troubleshoot our changes and see how it will play out in the simulation.
So the way our physical rover works is that we can connect to it wirelessly. So once we're all connected, we could then specify how exactly we want to control it. So whenever we launch our software, we could specify something like a keyboard, and once the software is all up and running, we could then use the arrow keys to control the rover.
For the simulation, we use a program called Gazebo, and the way we start the simulation is we use something called launch files, and these launch files have parameters that we could customize to affect the way the simulation runs. For the task scheduler, it's a central task scheduling system, and this task scheduling system assigns the rovers and tells it what to do, the activities it does. So when it initially starts, it assigns these dig sites to these rovers, which is based off proximity, which rover is closest to which dig site. From then on, the rovers determine the path they take, they handle object detection, object avoidance, and once they get there, they start to dig. The entire time, the task scheduler is keeping track of its battery life and its location, and once the battery life hits a certain threshold, it tells the rovers to come back home and charge. From then on, it assigns it a new task, and this process just keeps repeating.
Making a front end for our swarm is twofold. It allows a simple visualization of our rovers and their attributes, such as battery levels, current task, and location data. Another reason is to have a front end that is made using lightweight Python scripts, as opposed to running an entire simulation of our rover swarm in addition to the ROS code. Taking information directly from ROS and giving it to the user in an easy-to-read format almost entirely removes the need for a simulation software. This idea was one that our sponsor really liked when I pitched it, and it has room to be expanded upon in the future.
A challenge we faced during this project was we were originally provided some 3D printable parts to use to build everything together. What ended up happening was we found that these files were way too big to print and also took a long time to print. So what we ended up doing is we received a lot of help from the Black team in designing this smaller scale version so that we could use all of our hardware pieces on a physical platform for demo purposes.
So when we first started this project, we had issues understanding the code base. It was very complex, and it was built upon many different teams and their code. So what we did to overcome this is we would meet up with Daniel Silva, which was a previous team member of the Gold Team, and he would walk us through the code base over Zoom. He would help us understand the relationships of different parts of code. He explained to us how ROS worked, honestly. Initially, we had no idea. We never worked with ROS before, and he was a really big help to the team.
One struggle that I think we all faced was learning how to work with ROS, Gazebo, and the existing code base and become competent enough to work on an actual rover. Weekly meetings with our project sponsor as well as our advisor at NASA helped us a ton in becoming familiar with the project, and it kept us working on exactly what they wanted and expected from us. Seeing our tiny rover evolve from being just a few motors to the completed rover it is today was a huge motivator for our team throughout the semester. Creating our rover and learning a handful of new technologies was a stressful experience, but was a good introduction to something that will be common in the industry.
So how we process feedback from our sponsor was during our weekly meetups, we would present our ideas that we were going to try to accomplish for the next week, such as if we were working with a certain ROS package or if we needed to use a tool that we were not familiar with. We would tell him what we were trying to do, and he would most likely present us with another solution or send us a link to go learn somewhere. An example would be at the beginning of this project, none of us had ever really worked with ROS, so he walked us through all the different tutorial websites and showed us which steps to start and what we would need to learn to start with the code base.
We would have these weekly meetups where we would talk about our progress over the week and if we did anything. I feel like none of us want to let each other down. Like we wanted something to show off. So that was actually really motivational. We wanted to show something off to the team, like, hey, we did this. And that kept us in line.
The biggest motivation for me was honestly the fact that we could use RE-RASSOR to create a robot that would drive by itself, do intelligent swarm functions by itself. I just thought that was cool to have software be built onto a robot and have it be something that I contributed to.
Something that kept me motivated while we were working on this project was knowing what our end goal was. And given that we were able to accomplish that and have this little rover piece together and working was extremely satisfying, and that was definitely something that kept me moving forward.
So the motivation for wanting to work on my part of the project was I always wanted to know what was going on across the board. I wanted to know what was happening in every part of the project. So the reason I wanted to become the project manager was so that I could constantly be in contact with all the other different projects, such as the different Florida Poly one, which they are designing a quarter-ton rover, and I thought that was very interesting. So I wanted to see their updates and then contact with the black team and see how they're doing with their camera detection. So it was just very motivating to see it all come together from all the different teams.
So what really kept me motivated, or what really got me motivated, was the fact that this project would persist beyond my work. The idea that what I write will be continue to be worked on by other teams, other people, is a really nice thought to have, and it makes me really put all my all into this project and contribute as much as I can.